Okay, by now you should be really familiar with this table. We're going to use it extensively in this video. But what I want to do in this video is kind of bring everything together that we've learned so far. For everything from what sine, cosine, tangent, cotangent, secant, cosecant are, reference angles, which quadrant things are in, and the special triangles, 30, 45, and 60 degree angles. So you should be familiar for this, but right now I'm going to put this all together into one nice package. When you're trying to find the ratio of a certain angle, so let's say secant of 3 pi over 4, how do you find that? Well, the first thing you need to do is you need to determine which quadrant your angle is in. Is it in quadrant 1, 2, 3, or 4? And I'll show you how to do that. The reason you do this helps you find the reference angle. Remember, if it's in quadrant 2, it's 180 minus theta. If it's in quadrant 3, it's theta minus 180. If it's in quadrant 4, then it's 360 minus theta. So you have to remember that from before. So if you find what quadrant your angle is in, then that helps you find the reference angle, the angle in the first quadrant. Okay? And it also helps you determine the sign of the ratio, if it'll be positive or negative. Remember, all students take calculus. All are positive, sine is positive, tangent is positive, and cosine is positive. So that helps you by determining which quadrant you're in. That also helps you find the ratio, the sign of the ratio. Okay? Once you determine the quadrant, the next thing you need to do is find the reference angle. The reason you find the reference angle is this tells you what the ratio will be. Will it be square root of 3 over 2? Will it be square root of 2 over 2? Will it be 1/2? Will it be 0? Will it be 1? It helps you determine what the ratio will be. The quadrant will tell you what the sign of that ratio will be. So I'd like to do a couple of examples. For example, let's say we try to find the sine of 330 degrees. The first thing we notice is 330 degrees is greater than 270 degrees, less than 360. So it's greater than 270. 270 is down here. It's somewhere over here, so it's in quadrant 4. Sometimes finding degrees, it's very easy to find out what quadrant you're in. So it's in quadrant 4. So that tells me that the cosine is positive, the sine is negative, tangent will also be negative, and they're reciprocals. Will have the same sign. So the reference angle is equal, since I'm in the 4th quadrant, the reference angle is 360 degrees minus 330 degrees, which gives me 30 degrees. Right? So the sine of 330 degrees, since I'm in the 4th quadrant, the sine is negative, but it's the same as the ratio as the sine of the angle in the 1st quadrant, 30 degrees. So the sine of 330 degrees is the same as the sine of 30 degrees, except that it's negative because it's in the 4th quadrant. Sine of 30 degrees is equal to 1/2, so the sine of 330 degrees is equal to negative 1/2. So that's just using the two steps that I found. First, determine the quadrant of an angle, and then find the reference angle. That helps you find it. Tangent, 3 pi over 4. This is in the 2nd quadrant. The way you tell if it's in the 2nd quadrant is, I'm going to show you in the next slide how to find that, why it's in the 2nd quadrant, but for right now, just take my word for it. It's in the 2nd quadrant. I'll show you how to find that in the next board. Okay, the reference angle, since you're in the 2nd quadrant, the reference angle is pi minus 3/4, or 3/4 pi, which is just pi. And if you remember that little trick, if your angle is in something in terms of pi, you can cover this up, and that will tell you what the reference angle is. So the reference angle is pi over 4. So I'm in the 2nd quadrant. I'm trying to find the tangent. So in the 2nd quadrant, tangent is negative. So the tangent of 3 pi over 4 is the negative of the tangent of pi over 4. Tangent of pi over 4 was 1, because it's square root of 2 over 2 divided by square root of 2 over 2. So the tangent is 1. And I'm in the 2nd quadrant, so tangent has to be negative. So first you find the quadrant, then you find the reference angle, then that helps you determine, the reference angle will tell you what the ratio will be, and then the quadrant will tell you if it's positive or negative. Another example, cosecant of 240 degrees. Cosecant, 240 degrees, is in the third quadrant. If you think about the picture, like this one, the third quadrant would be, this is 180, this is 270, 240 is down here. So it's in quadrant 3. Cosecant, let's look at that. The reference angle is 240 minus 180, because I'm in the third quadrant, so I have to subtract 180 from my angle to give me the right reference angle of 60 degrees. So the cosecant of 240, since I'm in the third quadrant, cosecant is negative. Cosecant is negative, so it's a negative cosecant of 60. Cosecant is the reciprocal of sine, so it's equal to the negative of 1 over sine of 60. Negative 1 divided by the sine of 60. Sine of 60 is square root of 3 over 2. And this again comes from the table. Sine of 60, square root of 3 over 2. Find the reciprocal of that, and your answer is negative 2 over radical 3. 2 over the square root of 3. This is, when I ask for an exact answer, this is an exact answer. A decimal answer is not appropriate. This is an exact answer. Secant of 5 pi over 3. And this is where I wanted to explain this, what I was referencing in the last slide. Secant of 5 pi over 3. It's sometimes a little difficult to figure out where the quadrant is, but if you can remember this angle will be 0 going this way, and it'll be 2 pi if you're coming from this way. So 0 up to 1/2 pi, that's anything between 0 and 1/2 pi, that's in the first quadrant. Anything between 1/2 pi and 1 pi, that's in the second quadrant. Anything between 1 pi and 1.5 pi would be in the third, and anything between 1.5 pi and 2, so this is just quarter, this is just breaking it up into quarters. 1.5 pi and 2 will be in the fourth quadrant. So 5 pi over 3, if I just look at the ratio, 5 divided by 3. 5 divided by 3 is about 1.66. 1.66 is greater than 1.5, but less than 2. So that means that I have to be in quadrant 4. And this will work for any of them. So any ratios you want to find, just cover up the pi, find this ratio, and that will tell you which quadrant it's in. If this angle is between 0 and 2 pi. If this angle is bigger than 2 pi, then you have to take off multiples of 2 pi to get into 0 to 2 pi to be able to work this. So just find this ratio. In this case it was 1.6. That's between these two, 1.5 and 2. So that tells me it's in the fourth quadrant. My reference angle, and the reference angle for radians is very easy. Cover up the whole number. And the numerator is pi over 3, so the reference angle is pi over 3. So the secant of pi over 3, that's equal to, since I'm in the fourth quadrant, secant is the reciprocal of cosine. So cosine is positive in the fourth quadrant, so secant will be positive in the fourth quadrant. So secant of 5 pi over 3 is equal to 1 over the cosine of 5 pi over 3. Cosine of 5 pi over 3 would be the same as the cosine of pi over 3. So cosine of pi over 3 is square root of 3 over 2. Find the reciprocal of that, and it's 2 over root 3. For right now, I'm not worried about you rationalizing the denominator. You may, if you want to, you can multiply both numerator and denominator by square root of 3 over 3 to rationalize it. But I'm interested in just being able to get to here. If you can get to here, then the rest is easy to do. But getting to here is often the difficult part. So hopefully this helps summarize the steps you find for finding the ratios of any angle between 0 and 360.